Hello and welcome back to geometry. Today we're moving on to the next section, which is going to involve measuring segments. So talking about segment lengths, and then a really important concept called the segment addition postulate, which we're going to be using a lot over the course of the entire year. So the first thing we're going to get to is just measuring segment length, so finding distances on a number line. So if I want to find the distance between 2 points, and they're on a number line, whether that's a vertical or horizontal, like we have below, there's two different options we have to determining what the distance between those 2 points are. So the first one is I can count the number of units between the 2 points. So all I got to do is start at one point and count to the other. So down here, the first example right here asks for the length or distance from A to C. So if I wanted to know that, I start at point A, and then I can count 1, 2, 3, 4, 5, 6, 7, 8. So from A to C, I travel 8 units, so I have a distance of 8. Now, at the same time, I could instead use the coordinates. So I have the point A and point C here. I could use the coordinates, so the actual numbers associated with those points. So what I can do is I can subtract those coordinates one from the other. Now typically we want to do the big number minus the small number because that's always going to give us a positive value, which in this case, and it's very important to note, distance must always be positive. You can't travel a negative 20 miles or you can't walk a negative 10 feet. So distance is always a positive number. So if I look at AC again, rather than having to count from one point to the next, I could simply take the two numbers and subtract them. So I could take 2 minus negative 6. When I do that, the minus and negative turns into positive. So 2 plus 6 gives me 8. Now the other thing, in case I forget that I need to make sure that the right minus the left is the best way to go, let's just say I accidentally did negative 6 minus 2. Now in this situation, when I take negative 6 minus 2, I'm going to end up with a negative 8. But since we know that distance always has to be positive, then all I have to do is take that negative 8 and make it positive. So this is one time where we can just switch the signs because distance must be a positive value. If we look at the rest of the questions here, they want the length of BD. So if I want the length of BD, I need to go ahead and count or subtract the coordinates for BD. So I prefer the counting method typically. So 1, 2, 3, 4, 5, 6. BD has a length of 6. We could do CD. So if I'm counting from C to D, I could get 1, 2, 3. And then when I want BA, now in this case, notice BA goes from right to left, but as far as counting goes, I'm still counting in a positive direction. So I go 1, 2, 3, 4, 5. That distance is 5, even though we traveled to the left. So distance is always going to be positive regardless of what happens there. Now the other thing I want to point out here, the past couple of days we've been talking about naming lines and segments and rays. When we name a line, so line segment AC, line segment AC looks like this. So when I see that symbol on the top, I'm talking about the actual physical line segment, so the actual piece of the line. But notice down here, there's no symbol on AC. So on the symbol for AC, or no symbol on AC, what we're talking about, this means the distance from point A to point C. So anytime you see two letters posted together with no accompanying symbol, that's telling you need the distance from one to the next. Okay, so that's finding lengths on a number line, and that can be on the horizontal side to side or vertical up and down. It's no difference. Now the next thing we talk about are congruent segments. This idea of congruent is going to be a really key piece of what we talk about throughout the course of this year. When numbers, so numerical expressions, have the same value, you say that they're equal. For instance, you have equations like 2x plus 4 equals 12. So we're saying this numerical value on the left is equal to this numerical value on the right. So numbers can be equal to each other. When we talk about geometric figures, like line segments or triangles or circles and so on, when we have two segments, so two actual figures have the same length, then the segments are congruent. So when you think congruent, you need to think same. Same length, same area, same perimeter, whatever. When it says congruent, you're going to use the same. So numerical expressions, 2x plus 4 equals 12. There we use that equal sign. When we talk about congruence, we have a different symbol. So that congruent sign is an equal sign with a little wave right above it. So that's saying one segment or one triangle is congruent to the other segment or the other triangle. Down below, we try to kind of illustrate this point here. So notice the notation here. We're saying AB is equal to CD. That means the distance from A to B, 2 inches, is equal to the distance from C to D, 2 inches. This number is equal to this number. But if we don't want to talk about the actual length of the segment and instead we want to talk about the actual physical segment, notice on the other side then, we have line segment AB is congruent to line segment CD. So now we've changed the notation. We have this line segment symbol. As soon as we add that, we need to change our symbol between. Segments are not equal to each other. So line AB is not equal to line segment CD. They're congruent, and that's really important to make that distinction. So when I look below here, I'm saying this segment AB is exactly the same as this segment CD. So we're saying they have the same length. Now, in a picture, what's key to note here also is if you notice these red tick marks, these little red tick marks here tell you when things are congruent. So in a more complex figure, they might give you a figure with multiple sides and they might say this side is congruent to this side. So when you see those little tick marks in a picture, they're talking about congruence. They're saying this length is the same as this length here. Okay, so equal for numbers, congruent for actual figures. All right, the next thing, the segment addition postulate. This is a really, really important postulate that we're going to use a lot throughout the course of the year. So in the segment addition postulate, first we have to define this word between. So we know kind of what the word between means. We can visualize it, but it's hard to explain in words. So geometrically, what we're saying is for any point to be between two others, all 3 points must be collinear. So what we're saying is, like in the statement below, Q is between points P and R. So that means I have point P and I have point R here. In order for Q to be in between, it has to be on the exact same line that P and R are on. So for instance, I could not say if I put a point up here, if I call it point D is not in between P and R because it's not on the same line as the other 2 points. So in between is going to infer or imply that all of the points are on the same line. So they're going to give you a description of a problem sometimes. You just have to understand that when they use the word between, you're going to draw a straight line, put the 2 endpoints on either side, and then put the other point in between. Now, what the segment addition postulate says, so the part that's really, really important to take away from here is this equation right here. So PQ plus PR or QR equals PR. They're saying the length of PQ plus the length of QR is equal to the length of PR. Now, if we think about this a little bit differently, it should make perfect sense. Say we have city P right here. So this is one city. We want to travel to this other city, R. Now we start traveling, and as we travel through, all of a sudden we run out of gas. We have to stop at city Q. Now from P to Q, we traveled 20 miles. We pick up our gas, we continue our trip, and we continue on to city R. And from city Q to city R, we traveled a total of 70 miles. Well, so if we wanted to know how far we actually traveled from city P directly to city R, so if we want to travel from P directly to R, all we'd have to do is add the two pieces of our journey together. So 20 plus 70 gives us 90 total miles. That's all this segment addition postulate is saying. Take one piece of your line plus the other piece of your line, and you end up with the entire distance from one point to the other. So what that looks like in practice. So point S is between R and T. So it's important to note all 3 points are on exactly the same line. They want us to find the value of X given these different scenarios. So we'll start with this first example here. With these types of problems, it helps to label the picture so that you kind of can visualize what's actually happening here. So RS has a length of X. So we just put an X right between R and S. ST has a length of 17. And then RT, so the entire length. So typically I do something like these little braces here is 29. So the whole length from start to finish is 29. Now, our addition postulate said if I take the first piece of my trip plus the second piece of my trip, I get my total trip. So I take that and I can solve this equation now. Subtract 17 from both sides. And I get X is equal to 12. Okay. Now some of you might be good enough to look at this type of problem and you can say, okay, well, if the whole trip is 29, I can subtract out the piece I know, 17, I get what's left for X, and that's perfectly fine. Some of you will be able to do a little bit of this in your head, and I'm okay with that. Just be aware that some of the problems are going to get a little more complicated as we go. So now, let's take a look at another one here. So now question number 2, if RS is 11, ST is unknown, RT is 31, we need to know how far S to T is. So again, we could set up the equation, 11 plus X equals 31, and then we can solve. Subtract 11 from both sides, X would have to be 20. Or again, you might be able to see that, okay, well, if I take the full length minus the one length, I get the other, and that's perfectly fine. So some of them are pretty straightforward like this. Now, ones that are a little bit trickier are the ones like this third example. And so for this third example, they say RS has a length of 3x, ST has a length of 2x minus 6, and RT has a length of 24. Now it's not as simple as, well, if I take one piece minus the other, or if I take one piece plus the other, and I can just simply solve it pretty quickly. Now I have to set up my equation. So I have to understand that my 3x plus my 2x minus 6, so taking 3x one piece plus the other piece, 2x minus 6, will equal the entire length, 24. Once I have my equation set up, I can go through and start to solve it. So the first thing we'd want to do is combine like terms. So 3x plus 2x is 5x, minus 6 equals 24. I want to get the 6 away, so I'm going to add 6 to both sides. So 5x equals 30. And then finally I can divide by 5, x would equal 6. Now, the instructions here said find the value of X. So we have done what the question asked, but there are times where they're going to ask you to find the missing lengths. So they might actually say, what is the length of RS? Well, in that case, since we know what X now is, instead of saying 3 times X, I can say 3 times 6. And then that tells me that RS has a total length of 18. And then ST, I can find a couple different ways. First, if I already know that RS is 18, and I know the total length is 24, I can just subtract those two values. So 24 minus 18 is going to give me 6. Or you could plug the 6 in. So you could actually say 2 times 6 minus 6 and calculate that way. So whatever makes more sense to you, just be aware you're not always going to stop at X. You might actually go back and plug in to find the missing lengths as well. Okay, so next thing is your assignment. This is not the assignment you need to complete. We'll have a worksheet in class. So basically, if you were in class, you should already have this worksheet. If not, go onto Google Classroom, go on to the day for this lesson and go ahead and download and either work it out on another sheet of paper or print out the worksheet, but you're looking for the 1.2 worksheet to complete. And if you don't get it off of Google, you can always get it from class the next day. Work through as much as you can on it, and if you have any questions, make sure you ask us. We'll try to get you through whatever we can on here.